Okay, this is just a short video to provide you some hints on doing assignment 3. So consider this like an iterative assignment. If you don't get it right, please stick with it until you get it. Resubmit it as many times as it takes. It's that important. Okay, so let's just start. Number one rule for any assignment is read every single word in the document. Every single word. If there's a word in there, it's probably because I wanted it in there. Okay, there are basically two parts to the assignment. One is I want you to use the text-based relational notation. And then the second part is I want you to simulate what the contents of the tables would look like using a grid. A grid is just a goofy term, but what it basically means is I want to see rows and columns of the data, okay, as if this was a real database, okay? And remember, in a real database, after you've done the normalization, there won't be any duplicates. So most people, for example, would like to cut and paste from the Excel spreadsheet, pick the columns they want, copy and paste and get rid of the duplicates and just paste that into Microsoft Word. So let's take a quick peek at what that would look like. So here is an example of text-based relational notation. You guys know how this works, right? And then here's an example of a grid where the duplicate rows have been removed, okay? So this is what I'm after. I'm after in Microsoft Word. Don't do this part in Excel. Copy and paste, if you like, into Microsoft Word. So now you know what text-based relational notation looks like, underline and italics, and you know how to copy and paste the grid after you've removed the duplicate rows. Cool. Okay, so there's some assumptions. If you're looking at the data, there's a couple things in there which might make sense. One is like the student's major. In real life, a student could have multiple majors, but I'm trying to make this assignment kind of simple. And in real life, a course could have multiple prerequisites. But again, let's just don't make life complicated here. So I'm just go ahead and assume that a student can have one major, I call it the primary major, and only one prerequisite, if any. Okay, so if you just think about it, it's going to make a little bit of sense. So a course can be offered multiple times, right? Kind of makes sense, right? The same course can be multiple. And it's even possible that a course could be offered more than one time in the same semester. So if you're taking, CIS4301, and then there's another CIS4301 in the exact same semester, the way we tell them apart is through this thing called a section number. Okay. And so a student could, flunk out of a course and take it over a second time, right? That makes sense. So you took it in the fall and you go, something came up, and so you took it again in the spring the next year, that kind of thing, right? Okay, good. And then a single student can take multiple courses, and a single course can have multiple students. So though that phrasing should ring bells in your head, you ought to say, okay, I know what that means. That's a many-to-many relationship, and that means we're going to have to do something special. Okay. So, but before we begin this thing, let's just back up a little bit and start talking about how you would normally do this. In a real world, you'd probably go talk to somebody. You'd say, hey, is this what this means? Well, that's not really practical here. So instead, I gave you a topic that I hope you know a little bit about, a topic you can go look at. So I'm modeling this after the university schedule and the university catalog, okay? So you don't really have an opportunity to go up to somebody and say, what does this mean? Got it. So please do familiarize yourself with the terms. So for example, if I said, hey, when did you take that course? And you say, well, I took that in the summer of 2022. Okay, so that is a semester, a year and semester combo, right? Well, that's what I do. My semester format is a 4-digit year, then followed by the 2-digit month. So if it was 01, that would be the spring semester. If it was 06 starting in June, that'd be a summer semester. If it was 08 starting in August, that'd be the fall semester. Okay, good. And then a section number. I already mentioned that oftentimes we have the same course offered multiple times. So we have to have some way of telling them apart. So 110, 120, 130, that kind of thing. Okay, good. All right. So you need to be able to ask yourself some questions with the data, okay? So for example, do you know, I mean, hopefully you know the answer to these things, but does the same professor teach the exact same course every single time? And if you said, well, yeah, I mean, Dr. Jones is the only one that teaches Accounting 101. Well, yeah, but what happens if Dr. Jones, retires? Well, we just quit teaching the course? I mean, that, right? You can noodle this out, can't you? Is it always taught in the same room? No. Okay, is there anything else in there which kind of falls in that category where it could change every single time that the course was taught? Something could change. Okay, so that's the key. Are you able to see that some data changes every single time that the course is offered? Like the next time it's offered, it's not going to be the same professor. It's not going to be on the same day. It's not going to be in the same modality, whether it's online or face-to-face. At the same times, all the rest of that stuff. You should be able to figure that out. Okay, let's continue. There are some things that do not change. So for example, if we offer CIS4301 in the fall and the summer and the spring, okay, does the course description change? Does the prerequisites change? Right? Do the credit hours change? No. Right? So some things do not change every single time that the course is offered. Okay? So once again, you should be able to tell that there are an awful lot of the columns that do not change. This is important. Make a distinction between those columns that change and that might change every single time the course is offered, and those things that do not change every single time the course is offered. Okay. So let's look at the university. So here's an excerpt from the catalog. So here's a course. It's got the course and then a title or description, the number of credit hours, and the prerequisites. So those are the kinds of things that I'm thinking that do not change, right? If we offered this course 5 times, 100 times, or 0 times, this part would always be the same. Okay? Okay. And here's a copy of the schedule. Now, I'll confess, when you look at the university schedule, you're only seeing one semester at a time. But in my example, I'm using multiple semesters, okay? So it has the course name, the thing down here. What was that thing called? The one that tells you whether or not it's multiple times? The section number. And then spring 2020, I don't do it that way. I would have done 2020 and then for the spring semester be 01, okay? And whether or not it's a face-to-face course, and then the starting time and the days and the location and then the professor. So let's go back. Are you trying to tell me that if you looked at the university catalog and could you tell, whoops, that is not what I wanted to do. Okay, looking at the university catalog, does it have a professor assigned to it? No? But let's look at the university schedule. Does it have a professor? Yes, it does. Okay, we are kicking. All right, so you could start with things that are just fairly obvious. Just looking at the data, I see 2 entities right off the bat, which makes it so easier. The student entity, what's the first name? What's the last name? What's your major? That kind of stuff. I see professors. Like, okay, I see a professor and he's got a name, and he's got an office, he's got a phone. By the way, is there 2 professors on the list that have the exact same name, but are really 2 different professors? Is that possible? We could hire 2 people with the name of Smith? Yeah, I would think so. Okay. So those guys, student and professor, those are easy. I don't think anyone needs any help in there. And let's just ignore the grades for a minute, because that's the toughest one, and concentrate on how to take the schedule-related information and break it up into 2 chunks. One chunk that does not change every time the course is offered, and another chunk that does change. This is an extraordinarily important distinction. Okay, so those things that stay the same, I would probably call that catalog, because that's what the university calls it. And the parts that do change every time a course is offered, I'd call that schedule, because once again, that's what the university calls it. So that's 4 tables. I got one called student, One called Professor, one called Catalog, and one called Schedule. Woohoo! We're moving along. Okay, so of these tables that contain information, so one of them is going to need a compound primary key. It's not going to be the student because the primary key is going to be easy. It's not going to be the professor. Hey, by the way, what's the rules for picking primary keys? I mean, should I pick the guy's name? Well, I just told you there may be two people with the name of Smith, so that's not going to work. Okay. So this is something we've done. It's in the Chapter 3 videos. It's in the quiz you took. It's in some of the Excel spreadsheets. It's available in lecture notes. So you should be able to figure out how to make a primary key out of that schedule. You should, because we've done it 3 times now. Okay, good. All right. Remember now we have a thing where we have a student can take many courses and a course can have many students. Okay, remember that? Okay, good. We're going to need an intersection table that connects the two together. So I would call this thing grades, but you don't have to call it grades. I mean, you could call it anything you want. It's an intersection between student and schedule. Okay, so if student has one column in its primary key, and let's say schedule perhaps has 3 columns in its primary key, how many columns are going to be in the primary key of the intersection table? It's going to be 4. Yeah, it's the sum of the two. Okay, good. All right. So that's pretty straightforward. Now that you've got this intersection thing built, you could build a separate table that contained the grades. That might be your first instinct. And I will allow that. That's not a problem. On the other hand, after you built this thing, you took the intersection table and made a copy of it essentially and then tacked the grades on, you'd realize that everything in here is also in here. So I really don't need them both. So just to save you some energy and save you some time, I would suggest that you just reuse the intersection table and add the grades to it. Now, later on, we're going to ask you to solve the multi-column problem, but I'm recommending that you not do that now. Again, I'm just trying to get your mind around how to break up a table and how to do an intersection table. So I would recommend that you not. Okay? So far, so good. All right, so wrap up. So you got a stinking pile. That's what it says in the Excel spreadsheet. And you got it broken up into lots of tables. So don't forget to designate both the primary keys and the foreign keys, all right? Some of which are going to be compound, right? Okay, good. So what are the rules for picking primary keys? If I had a choice between a number and a string, I'd probably pick the number. Okay. Then look over the tables to see if there's any normal form issues that need to be dealing with. And then lastly, when you produce the grids, which is most likely going to be copying and pasting from that Excel spreadsheet, remember to remove duplicates. Okay, I don't want to see, student 1, 2, 3, 4, student 1, 2, 3, 4, student 1, 2, 3, 4, student 1, 2, 3, 4. The whole point of this is to reduce duplication. So after you're done, you still have duplication? Well, you have failed the mission. Okay, this is kind of making sense. I hope this is going to help you a little bit. And I'll see you guys again in the next video.